So today's webinar is entitled Building Partnerships for Robust Climate Risk Assessments, Why, What, How and When. Our presenter today is Professor David Karoly. David is the leader of the Earth Systems and Climate Change Hub in the Australian Government's National Environmental Science Program, and he's based in CSIRO in Melbourne. David is also an honorary professor at the University of Melbourne. David is an internationally recognised expert on climate change and climate variability. He was a member of the National Climate Science Advisory Committee in 2018-19 and the Climate Change Authority in 2012-17, where he provided advice to the Australian Government on climate change science and responding to climate change. He has also contributed to assessment reports of the Intergovernmental Panel on Climate Change in 2001, 7, 14 and 21. In 2019, David was elected as the Fellow of the Australian Academy of Science. I think we'll get started, David. I'll hand over to you to begin your presentation. Thank you.
Thank you very much, Sonia. And if you can please confirm that you can hear me okay at present. And look, welcome to everyone to this hub-related webinar. It's a different environment and a different world that we're living in at present under these COVID-19 restrictions. And look, obviously, there are a whole range of issues, but one of the things that isn't different now compared to the start of this year is that climate change and its impacts in Australia is an ongoing issue. And I took on the role as leader of the Earth Systems and Climate Change Hub at the start of 2018. And one of the major roles of the Climate Change Hub, or the Earth Systems and Climate Change Hub within the National Environmental Science Program, has been to provide the best available climate science information to underpin decision-making in all sorts of sectors and groups across Australia. In the government sector, from the federal government, state governments and local governments, to also provide information in the business sector, to local government, to communities, and businesses, whether they're large businesses or small businesses, and also even household decisions. And the talk that I'm going to give today is really about how the Hub has been working with a range of different users and stakeholders to build partnerships for assessing what is needed to manage climate risks. And I'm going to talk about that in a range of different contexts. And so what I'm going to do is progress through the slides, and there's going to be plenty of time to ask questions through the chat function at the end. And we'll also be making the slides and the references available. And the presentation is in fact recorded as well. So let me go to the next slide. And so what I'm going to try to do is essentially start with, why do we need to undertake these sorts of climate assessments or climate risk assessments? And the reason is, in practice, when we look at what's happened in Australia and around the world over the last 30 to 50 years, it is clear that climate change and the impacts of climate change have been having major impacts on almost every sector of the environment, on society and on the economy for at least the last 20 years or more. And so what we've now got to try to do is work out what we have to do in terms of managing the risks associated with these climate changes and climate variations, both the physical risks and how they impact different sectors, as well as the changes in those risks due to the changes due to human-caused climate change, how they're changing now and how they're likely to change in the future. We also have to look at and manage the transition to a zero-carbon economy, primarily because we know that if we're going to manage and reduce the risks associated with human-caused climate change, we need to change our economy, our lifestyle, so that we reduce our emissions. Now, what I'm going to focus on is primarily risk assessment due to climate variability and climate change. And the critical way that we know we have to do this, and I'm going to start talking about this, is building partnerships between experts in climate variability and climate change, essentially the climate scientists. We need to build those partnerships across the different user groups or different sectors. We've got to build strong partnerships. And I'm going to start off by talking about how the Hub's been involved in a number of cases of building partnerships and the approaches for then thinking about how to manage risks. I'm going to then focus on effectively the sorts of things we need to understand, essentially climate literacy. We know all about the sort of 3 R's, the reading, writing, and arithmetic type things, but everyone has their own personal experiences around climate variations and climate change. What we've got to try to do is to make sure that when organizations or impact groups or sectors are trying to understand how to manage their climate risks, that they need to think about two different types of risks. If you like, the acute risks in a sort of medical context, the acute risks associated with the 1 day or 1 season extreme events, whether it's heat waves or bushfires or local flooding, the sorts of weather-related climate extremes, as well as the longer-term changes associated with, for instance, sea level rise or long-term changes in rainfall patterns. We've got to think about that in the context of what everyone knows, and everyone has an opinion about understanding climate. I'm going to start off right in the beginning talking about some examples of the way that the Hub has built these sorts of partnerships already, but I'm also going to pick on one specific example which looks at and is relevant to both the acute risks and the chronic risks. And that example I'm going to use is understanding and managing climate risks within the electricity generation and distribution sector. And of course, I'm going to finish up by talking about, well, when did we need to do this? We've got to do it now. And in practice, we should have been doing and have been doing this understanding and managing climate risks for more than the last decade. So let me start about, well, okay, what do we need to do in terms of this understanding of climate change science? And some groups have been working on the understanding and have already got excellent, if you like, understanding of climate science. So if we know how to make use of the, if you like, the climate information, we can then use that already to look at what we can do. And if we understand, if we have excellent climate literacy to start off with, we can then use that information based on the latest climate change science to understand and encourage changes to the systems to manage the risks. But obviously, if we're going to try to manage risk, we've got to look at the risks and the opportunities that might exist in changing practices, changing and seeking to manage the practices. That might involve much more than just looking at climate information. We also have to understand and manage the vulnerabilities within the sector. And these vulnerabilities might be very different if we're talking about urban environments than if we're talking about rural environments. They may well be sector specific. The risks for the water sector may be very different from the agriculture sector. The risks for coastal environments may be very, very different from inland environments. So we've got to look at the vulnerabilities that are critically important and then develop partnerships between climate experts, climate scientists, and experts in the different sectors who know how the vulnerabilities of the sectors and how they're critical or how they're impacted by climate variations or longer term climate changes, and looking at how these groups may also be. One of the things the Hub's been doing is working with Indigenous communities across a range of different sectors. And the Indigenous communities within Australia have been very aware of changes in land and in environments, as well as changes in the ocean, and their close understanding of information about monitoring land and monitoring seas or water environments is critically important in understanding the vulnerabilities to climate variations and long-term changes. And they can often set recent variations into longer term changes, as well as managing vegetation, managing land, and managing water environments. We also have to look at how much our existing government policies or regulations or practices within different sectors, whether it's industry practices and procedures, account for a changing climate, because we now know that we are experiencing substantial differences. We can't use the historical context, the information over the last 50 years, or even the information over the last 30 years, to think about how much we can use to understand what's likely to happen in the future. And that's where understanding both the historical climate variations as well as the projected changes in the future is critically important in thinking about how sectors and risks might need to change in the future. Finally, because of the ongoing changes in the climate system that we've seen into the future, we know that we have in store major changes in the climate system that will continue to grow, and every extra degree of increase in global temperatures is going to lead to greater and greater impact. So if we're going to address climate change and reduce the unavoidable impacts of climate change, then what we're going to need to do is to avoid further increases in greenhouse gases as much as possible. And that means that we've got to think about not only adaptation to the impacts of climate change, we've also got to think about how we can reduce greenhouse gas emissions, not only within Australia, but reducing greenhouse gas emissions globally, and provide an example of how Australia and different sectors can contribute to greenhouse gas emission reductions, because all sectors and all our activities are likely to already contribute to greenhouse gas emissions. And we're going to solve this problem in terms of reducing greenhouse gas emissions and transitioning to a zero carbon economy only if we reduce emissions in all sectors and all activities. So all of those things are ways that climate change science can help us look at the risks and managing those risks across all the different sectors. Now, what I've talked about already is effectively what the climate change information how that can help, but it's clear also that we know already that we need to look at information across all of the different sectors. All sectors of society and all sectors in the environment are already being affected by climate change. And we know that urban environments, as well as rural environments, agriculture, human health, transport, water resources, electricity generation, all different sectors are all being affected. But the best people to tell us how those sectors are being affected are the people working in those sectors. And so if we want to address climate change and combine together the, if you like, climate science expertise, we need to develop partnerships between experts in each of the different sectors, whether they're farmers or health workers, government regulators, or companies that are working in the different sectors. We need to develop partnerships with each of these different sectors. And that means we have to co-design the different solutions. We can't just step back and have climate scientists provide the information about what's best to do. It's got to be through developing partnerships in terms of looking at what may be possible to do and the areas that are most vulnerable and the areas that are going to be most affected, both short term in the current period or over the next 10 to 30 years, as well as longer term. And there will be some cases where the longer term changes are much more important and unfortunately much larger than the short term changes. So one of the things that the Hub's been trying to do is to look at these sorts of what would be climate risk assessments, but also climate adaptation planning in each of the different sectors. And this is, if you like, the 5-step process in terms of a climate change health impact. It's the sort of, if you like, medical metaphor or analogy. There's a 5-step physical fitness program that was developed, I think, within the US military a long time ago. We're not talking about physical fitness here. We're really talking about the fitness within each of the different sectors, whether it's your company, your government sector, about how you can think about managing the physical climate risks and how they're going to impact your sector. And the most important part is to get together initially a team that involves both experts in climate as well as experts in the, if you like, the user sector, the stakeholders that are critically important, and get that team together and get them to start communicating, talking to each other. And what we've really got to do is to make sure, one of the things we've discovered is that often the words, the language that's used, the common discussion points is actually not well understood by all people in the team. The experts in the sector may not be familiar with some of the terminology that's used in the climate science. And some of the climate scientists don't really understand the sorts of impact areas. We've got to then have discussions, often through whatever format. Face-to-face is ideal, but obviously restricted at present. We've got to get those different people together, the subject matter experts and the climate experts together, to talk about what is the scope of the issues we want to look at. Is the focus of the issue going to be really only on the next 10 years, the immediate concerns, or is it much more important to look at timescales out to 30 years or even longer? And then what we've got to look at is what is the existing information in these areas. And I often say that, look, one of the best ways to assess the impacts of climate variations on a specific sector is to look at what extreme events or what impacts have been noticed over the last 30 to 50 years. In the past, what are the impacts in the specific sector of climate variations? And we know that climate has varied in Australia dramatically throughout history. And Indigenous experts, traditional owners also know that Australia is dominated by very large climate variations over time, not just year-to-year variations, but large decadal and multi-century timescale variations as well. So we've got to look at the historical information as well as making use of information from the different subject matter experts and bring those together and talk to them so that we can look at how the impacts of climate extremes or impacts of climate variations, as well as other factors like changes in vegetation or changes in agricultural practices or changes in coastal defences, have impacted the sector that we're looking at. And often we know that there's been major changes in technology over time that have led to major changes in the systems that are independent of the longer term climate change as well. And then what we've got to do is synthesize the information, pull it together, analyze it, and start to develop packages or plans that will lead to adaptation of climate change. And there are a range of different approaches. Excuse me. The Hub is not the first. There have been many groups within Australia that have tried to look at developing climate adaptation or climate risk analysis plans. So look, one of the things we've got to do is to look at, well, what are the different sorts of information and how are we going to combine these together? And obviously you're going to be needing information products around both the climate risks and the vulnerability areas. You're then going to be looking at an impact assessment from the climate risk information, as well as then the areas that will show how the climate impacts are assessing the specific sector, the vulnerability assessment. And these will all be done jointly between the sector experts and the climate science experts. And the ultimate goal is to provide a risk assessment that combines together the impact assessment from the climate science with the vulnerability assessment, so that this can then be packaged to developing an adaptation plan. Once you've done the risk assessment, the organization, the sector, the company, or the community group can try to understand, well, okay, what are the choices? What are the opportunities for managing those risks, and what can be done constructively to minimize the risks or seize opportunities? Now, as I was saying before, this is not the first time that this sort of approach has been suggested. There is, in fact, an Australian standard for climate change adaptation that sort of describes exactly the same sort of approach and is described in this figure or template. This Australian standard was developed within the engineering sector, I think, but specifically looks at climate change impacts for settlements, for urban environments, and specifically for infrastructure, and talks about a risk-based approach. Identifying the risk, analysing the risks, and then looking at how this could be treated in the adaptation area. What it doesn't say here is that what is critically important is the combination of the experts in risk identification within the sector in combination with the climate science information. And now what I'm going to do is talk about very briefly, two specific examples. The Hub's been involved in quite recently over the last 2 years in a number of different successful partnerships. One that was talked about, in fact, in one of our Hub webinars. I believe it was either last month or the month before, looking at climate risk assessment in the mango industry in the Northern Territory in Australia. And this was an initiative that was initially raised by the mango industry in the Northern Territory, who were concerned about the impacts of climate change and changes in temperature on the flowering and fruiting of mangoes in the Northern Territory. If you want some more information, please go to either the link that will be accessible through the PowerPoint presentation, or look on the Hub website, or look on the Hub webinar that was held either last month or the month before. But look, this has been highly successful in terms of providing information to the mango industry about what they need to do both now and into the future to plan for planting of mango trees, or choosing the right varieties so that the impacts on productivity associated with ongoing climate change are minimized within the mango industry. There, look, have been other impacts in a rather different area. Gondwana rainforests exist across the eastern parts of Australia because this was a region for which there is historical forest cover from millions of years ago. And this forest area spans from Queensland right down to Tasmania. There is, in fact, a World Heritage Area that seeks to maintain the coverage of Gondwana rainforests in Queensland and northern New South Wales, and then a separate World Heritage Area that spans all the way down to the Tasmanian, a cool climate, as opposed to the southern Queensland sort of warmer environment rainforests. The Queensland government, particularly the Queensland World Heritage Area that's managing the Gondwana rainforests, has been working with the Earth Systems and Climate Change Hub because they noticed that there had been additional stresses associated with drying in the Gondwana rainforest. You can find out more information again through the Hub web link that's provided on this page. But what was this we identified was that it wasn't really long-term changes in rainfall that were critical in this World Heritage Area. It was changes in the amount of moisture that was being provided by clouds. Cloud cover was a really critically important source of moisture for the forest area, because as you can see in this picture, there were often clouds lying over and covering the World Heritage Area forests, the Gondwana rainforests, because the forests were actually at relatively higher elevations. And the changes in the elevation of the clouds, what was called the cloud condensation level, was changing because of changes in the climate. The warming of the atmosphere was leading to higher in elevation cloud condensation level. And that was meaning the trees weren't getting as much moisture from the clouds. This is a critically important area. So look, I'm going to need to move on, because what I'm going to do is now talk a little bit about, if you like, the next aspect. I've talked about 2 partnerships, and now what I'm going to do is spend about 5 or 10 minutes, probably 10 minutes, on our understanding of climate variability and climate change, and how that then leads to better information about what's expected in the future. The starting point for this is, if we look at changes in greenhouse gas concentrations in the atmosphere, we see that there have been very rapid increases in carbon dioxide concentrations within the atmosphere. Numbers in this slide show the carbon dioxide concentration in 2017. We're now in 2020, currently at more than 410 parts per million of carbon dioxide. And the combination of multiple long-lived greenhouse gases means that the equivalent level of, if you like, warming influence from the long-lived greenhouse gases is more than equivalent to 500 parts per million of carbon dioxide in the atmosphere. The pre-industrial concentrations of CO2 were 280 parts per million, and we're now at higher levels of both carbon dioxide and carbon dioxide equivalent that at any time over the last million years, at any time over the multiple ice age and interglacial cycles. And that increase in carbon dioxide has led to rapid increases in global average temperatures. We can see on the left-hand side here, so on the right-hand side of the slide, the global average temperatures shown as changes relative to the pre-industrial level. And what we see is, after about 1900, there's been a very rapid warming of about 1.1 degrees Celsius, superposed upon which are large year-to-year variations, as well as decade-to-decade variations. And you can see that, in particular, in the period since about the 1970s, and for the most recent 5 years or so, we've had a rapid acceleration in global warming, superimposed upon which is large year-to-year variability. Now, there is massive variability in climate that I've talked about in Australia already. We know about Dorothea Mackellar's story that Australia is a land of droughts and flooding rains, and there are many different climate factors that influence the variability of weather and climate across Australia. And so we can't just talk about climate change, we also have to understand the typical patterns of climate variations that are affecting Australia. The differences between the weather systems, highs and low pressure systems that affect southern Australia, the weather systems that move up from the Southern Ocean, are quite different from the weather patterns that affect tropical Australia. The seasonality of the wet season in the warm period from December through to March in northern Australia is in dramatic contrast to what we expect with heavier rainfall and the dominant rainfall seasons being in the cool season across much of the far southern part of Australia. So we've got to understand the seasonal cycle, we've got to understand that the regions which bring the dominant rainfall. We've also got to understand the modes of variability, the changes in the excuse me, changes in the weather patterns, changes in the moisture transport, as well as the year-to-year variability. And we know that there's major year-to-year variability associated with temperature variations in the Pacific Ocean associated with El Nino and La Nina. Most recently, we saw in 2019 major temperature variations in the Indian Ocean associated with the Indian Ocean dipole, affecting rainfall in 2018 and 2019 over much of Australia, particularly Eastern Australia, and also changes in the weather systems and wind patterns over the Southern Ocean. So all of these different factors are critically important for the year-to-year variability. We've got to monitor them and recognise that impacts on extremes will happen from both year-to-year variations, natural climate variability, as well as longer-term climate change. Now, what have we seen? Well, let's come back to Australia now. And what we see, if we look at the Australian temperature variations, again, we see large year-to-year variability. And for the Australian average temperatures, 2019, in fact, set a new record for the hottest year that we've got since high-quality observational data has been available over much of Australia. And the high-quality temperature record for Australia is really only available since 1910. And for the first 40 years or so, from 1900 to 1950, there was large year-to-year variability, but no pronounced warming. And then from 1950 onwards, we've seen a warming from about, in this scale, where the scale is temperature variations relative to a baseline period of 1961 to 1990, that baseline period, we see temperatures going from about -0.5 up to, in the last 10 years, +1. In other words, we've had a warming of 1.5 degrees in Australia compared to the 1.1 degrees we've seen in the global average. In other words, global temperatures are warming less quickly. Australian temperatures are warming at a faster rate, about 1.4 times the warming rate that we see in the global average. We've got to understand the year-to-year variability. For instance, the temperatures over Australia are substantially influenced by El Nino, as well as other modes of variability. We can see large year-to-year variability, but also a long-term trends. And we can't explain the recent trend in Australia or globally without taking into account the increases in greenhouse gases. Now, rainfall is another critically important factor for many, many different sectors, whether it's agriculture, environment, water resources, many, many different areas. And we've seen much, much more complicated changes in rainfall, which are different between the different seasons. And what is shown here is not time series, but a sort of maps, because the pattern of rainfall changes are very different across Australia. And this shows with coloured maps how the rainfall in the last 20 years, up until 2018, how the rainfall in that period compares to all other 20-year periods since 1900. And I'm going to focus on the left-hand side at the cool season, or the wintertime period, what would be the dry season in Northern Australia, but it's the wet season in Southern Australia. We see that there's actually been large declines or record low rainfall in the southwest of Western Australia, in the far southeast of Queensland, and in fact, much of southeastern Australia, we get very much below average rainfall. And this has been an ongoing trend over the last 30 to 50 years across Southern Australia, declines in cool season and winter rainfall. Whereas in Northern Australia, if we switch to the warm season, the wet season in Northern Australia, we've actually seen an increase in rainfall. In fact, record high rainfall over the last 20 years across much of the northwest of Australia, and increases in rainfall, much above average rainfall throughout all of Western Australia and the North Queensland region. So we get quite different contrast in rainfall patterns, primarily due to changes in the weather systems and changes in the wind patterns that are driving the rainfall over Australia. But it is critically important to recognise that these are not just, if you like, one-year variations. These are changes that have happened over the last 30 years or so, and appear to be associated with long-term trends over the last 30 to 50 years. Well, let's now look at some specific information, not just on the changes in the means, mean temperatures and mean rainfall, but let's look at, and I'll come back to oops, let's get back to the right side. Sorry about that. I was using the cursor to drive, and now I've just got to get back to the right slide. What I'm looking at here is Victoria, just because the Victorian government organised a new climate science report and new information on climate projections. And there are a couple of examples of graphics here that talk about changes in unusually hot days and changes in bushfire weather associated with climate extremes. And what we know is that many of the major impacts of climate are associated with changes in the frequency or intensity of the extreme weather events. And what we know is that ongoing warming of the climate system leads to increases in heat waves and hot extremes. This metric is the number of unusually hot days across the whole of Victoria in the top left-hand panel here. And it's the metric that's used is the top 1% of days relative to the whole observational record in Victoria over the last 100 years. We would expect the top 1% of days to occur in terms of temperatures about 4 days per year. And what we can see is that for the period from 1910 to 1970, yes, there's year-to-year variability. The 1939 was a very hot period with bushfires. In that period, we can see the number of very hot days varies year to year. And then from about 1970 or 1980 onwards, we've seen a dramatic increase in the very hot days. And so in the 2010s, we've had effectively since 2012, no year that's had fewer than 5 and many years with more than 10 days that have had, if you like, days. And we've seen effectively a dramatic increase, a more than doubling, nearly trebling of the number of very hot days across Victoria. Major impacts associated with that. We also see, associated with those very hot days, as well as the drying in Victoria that we've seen as well, is a major increase in bushfire frequency, or the number of spring days with very high and severe forest fire danger index. And in particular, what this graphic shows is that the springtime bushfire weather associated with dry winter conditions and high temperatures, you're getting a dramatic increase in these severe and extreme bushfire days happening much earlier in the season. So there's less opportunity to have fuel control burns because the extreme bushfire conditions are happening earlier in the season. And in particular, we saw a lot of that, not just in Victoria, but across Australia in 2019. Now, the other important thing to look at and to understand is we often will make use of projections of future climate change from climate model simulations. Crystal balls don't work very well for understanding future climate change. So what we have to use is to use climate model projections, simulations of climate data, climate variations from day to day and year to year into the future. If we compare those climate model simulations against observational data for Victoria, on the left-hand side are the changes in temperature, and the observations on a decade-to-decade variation are the solid black line here. The band is the projections that had been made from 1995 through to the 2030s and even further into the future. And what we find is that the observed changes over the last 20 years or so have been tracking at the upper range of the climate model projections. And similarly, if we look at what's been happening with the wintertime and cool season rainfall change, we've seen that the rainfall change, which looks as though it's a pretty monotonic decline when we look at the decade-to-decade average. Yes, there's large year-to-year variability. We can see very wet conditions in 2010 and also very wet conditions in 2016. But longer term, we see an ongoing decline in rainfall, and that's been tracking at about the worst case of the climate model projections. So if we're looking at climate projections into the future, you want to make sure that you don't just assume that the climate change is going to be in the middle range, but look and compare with what's happened over the last 30 years or so with what's projected into the future. And for Victoria and much of Southern Australia, it's really a case of unfortunately, looking at the worst case. There's a whole range of summaries of climate change impact projections. The most recent State of the Climate report, they come out every 2 years, is climate projections prepared jointly and climate information assessing the state of the climate jointly between the Bureau of Meteorology and CSIRO. They've been provided every 2 years from 2012 up until 2018. I like this one because it's a very nice graphic, talks about the projected changes and impacts of climate change across Australia. It comes from the 2016 report. The text and the projections and the impact areas are exactly the same in the 2018 report. And the 2020 State of the Climate report will be coming out later this year. The planned date for release is October or November at present. I'm not going to talk about each of the different areas, but many of these impacts are what we've experienced in 2019 already. And again, I've shown this graphic already. We see record high, in this case, the annual average of the maximum daily temperatures, rapid increases in that maximum temperatures across Australia, and that was exactly consistent. What we see in this is that we can do an assessment of what are the chances of this new record high annual temperature just being due to climate variability or the long-term trend due to climate variability. It's virtually impossible that natural variations could have caused that record Australian temperature in 2019. However, 2019 was also exceptional because it set a new record low annual rainfall across Australia, mainly due to natural variations, reductions in rainfall associated with the interdecadal Pacific Oscillation and the Indian Ocean Dipole. And what we see is that the Indian Ocean Dipole, as well as changes in the wind regimes over the Southern Ocean, led to reductions in rainfall over southern and southeastern Australia, as well as in southern Queensland. And that's what led to the ongoing continuation of the drought. We had these two record extremes. Climate change probably contributed to the long-term rainfall declines over southern Australia, but it was mainly due to natural variations. I'm going to run out of time here, so let me speed up a little bit and get to the example that I want to talk about. We know that the spring and early summer bushfires in Australia were unprecedented in terms of the drought and the extreme temperatures. Part of this was due to ongoing climate change contributing to the record high temperatures, as well as natural variability leading to the ongoing drought and record low rainfall, particularly impacting on the Gondwana rainforests in southern Queensland, which experienced extreme bushfires for the first time ever. If we look at Forest Fire Danger Index for December of 2019, that we can see that almost all of Australia, particularly Central Australia and Far Eastern Australia, experienced unprecedented high forest fire danger index in the December 29 period, and in particular, all through the period from October of 2019 through to January of 2019. And we're lucky now that we've had much wetter conditions across many parts of Australia in 2020, but not everywhere, and there's still ongoing drought in many parts of Australia. I'm going to spend a few minutes now talking about an example and then finishing up. What I'm going to do is talk about an example that I haven't really talked about before, and that is the electricity sector. Look, the electricity sector is critically important in the transition to low emission technologies, but you also know that the electricity sector, particularly the distribution networks, but also the generation networks, are very sensitive to extreme weather events like bushfires or extreme strong winds that are likely or that have led to the blackouts in South Australia in 2016, associated with lightning, associated with tornadoes or very strong winds that led to breakdown of power transmission poles and power transmission networks in South Australia. In recognition of the importance of the electricity sector for modern lifestyle across Australia, for industry and for communities, the Australian government has invested some funding into a project called the Electricity Sector Climate Information Project, which was started in 2019. And there's information available on it. It was designed between CSIRO and Bureau of Meteorology in terms of the, if you like, climate experts, together with the Australian electricity, now I'm going to get it wrong, the Australian Electricity Management Operator. No, I've forgotten what AEMO stands for. I apologize to everyone associated with AEMO, but AEMO is essentially the electricity operator that manages all the electricity generation and distribution systems across Australia, except for Western Australia, and it manages the systems for both generation and distribution to all the users across Australia, and is working on this electricity sector climate information. And it's critically important that they've already undertaken sets of assessment and looked at where will be best to, first of all, manage the existing distribution network and the sorts of impacts that are critically important. Increasing temperatures cause the sagging of power lines in many different areas. Bushfires will lead to, obviously, major impacts on power distribution systems. Strong winds can be really critical, and severe weather will be critical for blowing over power lines. But temperatures are also critically important, and record high temperatures or extreme temperatures are critically important for what are called the interconnectors, the systems within the transition system that provide a network between the underwater Bass Strait power line from Tasmania into Victoria. That is temperature sensitive. The interconnector between the network in South Australia into Victoria is also temperature sensitive. Many power regulators in terms of transformers that transform from the high voltage to the lower voltage, temperature sensitive. All of those systems are temperature dependent. So higher temperatures and increases in temperature extremes when many people want to run their air conditioners are going to be temperature sensitive. So at a time when demand is highest in extreme temperatures, it's also a time when the system, both distribution system and the generation system, is very dependent upon and sensitive to or vulnerable to extreme temperatures. So this assessment project, as a partnership between climate scientists and the electricity generators and distributors, is critically important in trying to plan for future climate change. So it's time for me to finish. And what I'm going to do now is hand over to Sonia Bluhm in just a second. But what I've talked about is really that climate change is already leading to significant changes in climate risks. And many of those risks we can make, if you like, high confidence assessments of those changes. Changes in increases in heat waves, changes in the increases in coastal extremes, as we saw along the New South Wales, central New South Wales coast, just last week, increases in fire weather that we've seen, particularly in the spring and summer of 2019, reductions in winter rainfall in the southwest of Western Australia, in Victoria in South Australia and New South Wales as well, and increases in heavy one-day rainfall that we saw happening in many parts of Australia at the end of the drought. There are many other extremes that are much harder to talk about, but it is in fact the case that it is the changes in extremes that are likely to have the biggest impact. And if sectors want to take into account climate risks, they need to think about climate variability as well as climate change. And if you're going to work on a climate risk assessment, we need to have partnerships between the different sectors or users of the information, as well as climate experts, to combine together in a productive partnership to make sure that we can synthesize climate expertise or climate information together with sectoral expertise to plan for and manage climate risks in the future across all the different sectors. I've taken up more time than I had hoped, but Sonia, I'm going to hand back to you, and we've got plenty of time for questions, I believe.
That's right. Thanks, David. Thanks for a really great webinar. You certainly fit in a lot of information there. So we have had some great questions come through, as well as some great discussions on the chat function. So if you've got questions, keep sending them in. We'll get through as many as we can. We can go over the 1 hour that we've got allocated for the webinar too, so hang around if you're interested. Or if we don't get to your question, get in touch with us. There's some contact information there. But I might start with a bit of a general terminology question that's come through around, do we need to start changing how we refer to climate change and stop saying climate change but referring to human-induced warming or something similar? What's your opinion on that, David?
Look, that's a really good question, and many people will be aware that global warming used to be a more common term than climate change, but the international community, I think it's also the community in Australia, has recognised that it's critically important to recognise that there are multiple impacts across different components of the climate system, and that the term climate change is believed to be a more useful term because it talks about things like sea level rise, as well as rainfall changes, as well as changes in severe weather in some instances, as well as temperature change. So if we only talk about global warming or Australian warming or heating or things like that, it suggests that the only thing we need to worry about are the temperature increases. And in fact, that rainfall changes in many sectors are much more important than the temperature changes. Yes, the temperature changes are clear, but it's the other aspects of the climate system that are also critically important.
Great, thanks, David. We have another couple of questions around timeframes, specifically from Bruce from IAG, who says the insurance sector needs to get people and planners and builders to think of changing climate impacts over the entire lifetime of structures, so it's centennial timeframes. How do we get the attention of the punters through the cost of their insurance premiums or what? And another comment also came in around how do we get punters to think on the decadal timescale? So we're really looking at that decadal to centennial sort of timescales.
Well, that's a really good question. And often I would argue that many people will be most sensitive to the hip pocket, to premiums. But we've also got to talk about looking at what's happened recently over the last 30 years in the lifetime of people. Because people's sensitivity and experience of extreme events will typically only be for the period that they're most familiar with, often their working careers. And what we've got to try to do is to look at that information and show what's changed, not just using people's individual experience, but using experience over the period for which we've got high quality observational data on daily variability and extremes, and we now have good high quality data for more than 100 years across Australia. So we've got to combine together the information for the sectoral experts with reliable long-term climate information. But we also need to recognise, as the question suggests, that this is not something which is only going to happen in the future. We've also got to recognise that we have been seeing the major impacts of climate change across Australia, not just in 2019, but for more than the last 20 years. And there have been major impacts on changes in heat waves and temperature extremes, on sea level rise and coastal erosion. This is not something that's happening in the future or just happening in the 2020s or even the 2010s. It has been ongoing, affecting the environment for many decades already across Australia, since we've seen those substantial changes in temperature extremes and substantial changes in temperatures.
Thanks, David. And the next question is around how do the actions across this area align with the UNDRR, which I believe is the United Nations for Disaster Risk Reduction, principles and practices. And also a statement that the ACCC is currently conducting investigations with some councils about the relationship between planning and insurance considerations at present.
Look, the United Nations Disaster Risk Reduction principles are critically important for looking at managing the sorts of climate risk factors, but also looking at the vulnerability across different sectors. And the UN Disaster Risk Reduction principles very much seek to, if you like, take into account partnerships between, if you like, the impact areas, the sectors, whether it's water resources or coastal areas or fire or severe weather or tropical cyclones. Each of those different areas needs to bear in mind the climate information, but also the sectoral information and the vulnerabilities. Because the vulnerabilities may well depend upon what's happening with, if you like, the infrastructure that's at risk. You know, people moving, communities moving to either tree change or sea change and putting themselves more at risk associated with either sea level rise or bushfires in forested areas. So it's not just climate information that's important, it's also the other aspects as well. And so yes, those are very important. And then I think there was a second part of the question around the ACCC. And yes, nationally and globally, the United Nations Task Force on Climate-Related Financial Disclosures, the TCFD, has been critically important in pointing out that all companies, all businesses should be taking into account the impacts of climate risks associated with the physical risks of climate change, as well as the transition to a zero carbon economy in their scenarios for their company for planning into the future. So the TCFD provides guidelines about how to take into account not only climate risks associated with changes in extremes, but also climate risks associated with a transition to a zero carbon economy on individual year basis, but also planning into the future. And the ACCC is now requiring, if you like, all companies in their annual reports to try to, well, to include reporting of their assessment, because all company directors need to take into account in the plannings for companies the risks of, across all areas, and climate risks, both transition risk and physical risks, need to be taken into account in managing all companies in all sectors and in all governments, whether it's local councils or all areas.
Thanks, David. We had a few more questions come in around how do you best incentivize people for that to participate in co-production, and that, you know, acknowledging that it takes time and resources, and wondering if you could give any thoughts on what sort of time and resource commitments are usually needed for co-production, and how we can incentivize stakeholders to participate in that process.
Look, I am probably not the best person to answer that question, but it is certainly the case from our hub experience, where we've got a group of climate science experts. Our knowledge brokers have been involved in these sorts of partnerships that I talked about with the mango industry, with the Gondwana rainforest in southern Queensland. They would say that to build the partnership and to develop it, it will take a commitment of at least 1 year and probably much more like 2 years to develop the understanding, as well as working around the existing commitments. You may be able to do a short-term, if you like, impact assessment, but then the planning, the adaptation planning and the implementation of the adaptation plan, as well as the robustness of the plan, will really require a commitment of 1 to 2 years or more. And it's also important to recognize that when a plan is developed, it needs to be updated and reviewed, not just on thought about, how would I say, a document that you prepare and file away. It's something that needs to be an ongoing review over time and updated and reviewed, probably on an annual basis, but definitely on a 5-year basis.
Thanks, David. We've got a really interesting question from Bruce, who asks, should commentary on future climate projections include structured expert judgment in areas where the science cannot yet provide sufficiently definitive answers?
Look, the questions about whether science should be providing information with definitive answers, look, there are many areas of climate which are uncertain, associated, for instance, with future temperature change, because we know that we cannot, even with a crystal ball, talk about high confidence assessments of what the global temperature will be beyond 2050. And that's because that depends upon what the world and global economy decides to do about using fossil fuels or transitioning to a zero carbon economy globally. So we have uncertainties associated with future emissions. We have uncertainties associated with the differences between different climate models. That does not mean that we cannot provide robust information. Some of that robust information might be, how would I say, conditional. This is what we would expect if global temperatures reach 2 degrees, or what more is expected if global temperatures reach 3 degrees, or how much more it will be when global temperatures reach 6 degrees of global warming, and if global temperatures do reach 6 degrees of global warming, which some climate models suggest, then there will be many locations on land, if global temperatures reach 6 degrees, for which land average temperatures would reach 10 degrees above pre-industrial levels. And that's a very different world. So yes, we can provide uncertain information, conditional on certain other factors. And yes, there can be and should be planning for many things which are not definitive, but we can provide probability ranges or confidence assessments about the sorts of changes.
Thanks, David. The next question comes from Sarah, who says, I think there is a strong appetite among stakeholders for partnering to get good tailored climate information. The barriers are often seen to be the complexity in information and the underlying assumptions. Has the Hub seen an evolution on how it is communicating and co-designing this information? Are more risk assessments looking for hard data or more quantitative summaries?
Look, that's a really good question. And again, it's complicated to answer because there may be some specific examples where, and some experts for which quantitative climate projections are required, for instance, for doing crop modeling or water resource planning or structural design around extremes and changes in extremes. So there are many application areas for which experts in different sectors, whether it's agriculture or environment, are trying to do their own modelling, need sub-daily or even daily weather data into the future based on climate models. There are other groups that may well just want information more based around scenarios and risk assessment and looking at specific, more qualitative information, but they often will also be wanting to get information to stress test, if you like, their business or stress test their environment based around some extreme cases, like examples that have happened in the past maybe it's now in the recent past, the sorts of examples of the spring and summer of 2019 can be used as an excellent or disastrous stress testing for many businesses. The same happened in Black Saturday in 2009, can be used as stress testing for a number of different areas. And it's how those sorts of examples impacted on your business, on your sector, on your local community that can be used to look at, well, okay, are those cases going to become much more frequent in the future? And unfortunately, the information we have is that those stress testing examples, bushfires, temperature extremes, extreme sea level, are all getting much, much more frequent in the future, whether it's over the next 10 years, over the next 30 years, and over the next 50 years. The frequency and intensity just gets worse over the period up until 2050 or more.
Thanks, David. We've got another question from Pira, which asks, most infrastructure guidance on climate risk assessments are currently directing the use of RCP 8.5, so a high emission scenario, for 2090 projections for long life assets. What are your thoughts on which projections should be used or scenarios should be used post Paris Agreement?
So that's a very good question, and relevant to more the longer term projections. So first of all, it's important to provide a little bit of background. I didn't talk specifically about different emission scenarios into the future, but what we know is from now until 2040, there will be relatively little differences in the projected global warming associated with the different emission scenarios. The temperature change is pretty well locked in. We don't know exactly what it will be, but we do know that irrespective of the emission scenarios, the warming out to about 2040 is essentially not dependent on the emission scenarios. It's only from 2050 onwards there are likely to be substantial differences. And the RCP 8.5 is the high emission scenario. Unfortunately, when we look at emissions from 2000 to 2020 or 2019, we have been tracking fairly closely the high emission scenario, despite the actions for which the world has been seeking to reduce emissions. We are still tracking very close to the high emission scenario. I would argue that it is important to use the high emission scenario because, first of all, in terms of stress testing, which is what I was talking about before, you really need to think about, in some sense, the worst case, because that's going to provide the stress test that you need to consider. And if your system, if your sector is robust to the high warming, high emission scenario, then it's likely to manage. The critical other aspect of this is that there are some newer climate model simulations that are indicating that we should be using the, in some sense, high warming simulations as well. Because as I talked about for Victoria, the observed changes in Victoria for both rainfall decline and increases in temperature across much of southern Australia have been tracking at the worst case in the climate model projections for the most recent 30 years. And if we're looking at stress testing the system, we're probably better in southern Australia, at least, at using the warmest, driest model simulations, not the mid-range. And there's been a tendency to look at the mid-range across the different cases. So looking out to 2090, there are some aspects of the climate models which are not, some aspects of the global Earth system which are not even yet taken into account in future projections, such as melting of permafrost and the release of more methane, or loss of rainforests in the tropics, like the Amazon rainforest. There are aspects that aren't fully included in all the climate model simulations. So we need to recognize that actually probably the RCP 8.5 and some climate models may well still be underestimating future temperature change, even though some people have argued that, well, we couldn't possibly release that amount of greenhouse gases because the world is aiming to transition to a low carbon economy. Well, there's differences between what's happening in practice in terms of the objectives in governments around the world. And so I would argue that it is still best to focus on the RCP 8.5 or the high emission scenario out to 2090. Can I add one more thing, Sonia?
You can, David. Go for it.
We also need to recognise that climate change will not stop in 2090, and that for infrastructure, particularly coastal infrastructure, warming will continue beyond 2090 unless we rapidly reduce our emissions. And sea level rise, even if we do rapidly reduce our emissions, will continue beyond 2100, likely to 2300 or longer, even if we were able to stabilize our global temperatures in 2050. We would still see ongoing sea level rise for at least 300 years or more beyond that, and that means ongoing inundation in coastal infrastructure. So look, even though the projections only go to 2090 to 2100 in many of the climate model simulations, we need to think about beyond 2100 for long-lived infrastructure.
Thanks, David. Just in recognising that we've gone quite a bit over time, we might have to leave it there. We have had still quite a few great questions I haven't got around to. So I would suggest if you do want your question answered, if you wouldn't mind just sending an email to the info@nestclimate.com.au, and I'll make sure that the Hub and David gets back to you with a response as soon as possible. So please do feel free to get in touch if we missed your question. And I apologise for not getting through all the questions. So that does bring us to the end of the webinar. So thank you, David, for your really informative and great webinar. And also thank you to everyone for attending, for providing time, and for your great questions and really good commentary in the chat box. Just a reminder that this webinar has been recorded, and we will be providing a link to the recording on the Hub's website by the end of the week. And that link, as well as a link to the a copy of the slides, will be sent to all attendees and registered people of this webinar. So you'll be getting that by the end of the week in case you feel the need to watch it again. If you do have any questions or inquiries about today's webinar, like I said, here's a variety of ways to connect with the Hub up on your screen. Please do get in touch. As I said, we'll try to get back to anyone who sends their questions through to us. So, and just another plug that we will be having another webinar next month, and that you'll be receiving an email with details about that closer to the day. So keep an eye out for that. Thanks again for attending, and we look forward to seeing you at the next Earth Systems and Climate Change Science Hub webinar. Thank you.